Moving into the last gas law that we're going to cover. There are others out there, but the last one that we're covering here is Dalton's law of partial pressures. And when we have a mixture of gases, then each one of them contribute to the total pressure. Air, of course, is a mixture of gases, and we've mentioned this before. And so each of them contributes a little bit of pressure to give us our total pressure. It seems pretty obvious that if you have a gas that has a certain amount of pressure and you add it to another gas that has a certain amount of pressure, could be the same, could be a different pressure, then when you have them together, they have more pressure. That literally is all of it. So the formula for this is that the pressure total is equal to, I'm going to use the mathematical symbol here for sum of all the pressures. And usually we put some kind of notation down here for the different pressures, but it's the sum of all the pressures. Well, that means it's really the sum of pressure of gas 1 plus the sum of pressure of gas 2, and if you have more gases, so on and so forth. That is it. Here they have an example that simply says it doesn't matter what gas or combination of gases we have. If we have 1 mole of gas, this is Avogadro's law there, then because of Avogadro's law, we know if we have a certain amount, 1 mole in this case, then we have a fixed volume. That'd be the 22.4 liters. Well, then from Boyle's law, we know that if they're at the same temperature, a constant temperature, more specifically standard temperature and pressure, that then means that we have a fixed pressure, and it would be your standard pressure, 1 atmosphere, or any of the other units that we've used for it. Same thing with air. It's the same chart that was on that first slide. I'm going to move right along here. There are lots of places where this matters. One big one is scuba. You can get something called the bends if you go down too deep with normal air, or you come up too fast. The gases that are dissolved in your blood will start to expand. It can be incredibly painful. It can even be dangerous and deadly. I have been told that there have been some euthanasias of pets that have been done by just rapidly decreasing the pressure in there, and they, because of the lack of air, they kind of pass out and go to sleep, but it is literally the expanding gases in there that kill them. And so you do have to be careful with things like that. Side note, SCBA for things like firefighters, when you're wearing a gas mask on land, the U there is just underwater, but the SCBA equipment is the same thing. We usually put the oxygen gas, which is what you want to breathe in there, and then some other gas to increase the pressure to help push that oxygen out, much like an aerosol can you would as well. But anyway, a scuba tank contains O2 with a pressure of 0.45 atmospheres, and rather than labeling these 1, 2, I'm going to just label as pressure of O2 there, and helium at this pressure here, pressure of helium, and we're asked what is the total pressure total in millimeters of mercury in the tank. Normally, this would just be add then, the pressure total is equal to the pressure of O2 plus the pressure of helium. Why did I say normally? Well, you'll notice that our units here don't match. We have millimeters of mercury and atmospheres, and we want the final answer to be in millimeters of mercury. I'm going to have to convert that pressure of O2 from atmospheres to millimeters of mercury. And we know that 1 atmosphere is 760 millimeters of mercury. And so that's going to give us 342 millimeters of mercury. Well, now we can plug that in here, 342 millimeters of mercury, and then we're going to add that to the pressure of the helium gas at 855 millimeters of mercury. And so our pressure total is going to equal then 1,197 millimeters of mercury, which with 3 sig figs is going to round off to 1,200 millimeters of mercury. Now, this is one of those awkward times where that one's our significant figure and that last zero is not. The bar over a non-ending zero can be used for that. Of course, we can turn this into scientific notation as well, 1.2 times 10 to the 3 millimeters of mercury to show our significant figures. Once again, on this one, they've given us mixed units, but we're told that there's a mixture of helium gas and oxygen gas with a pressure total of 8 atmospheres, and we're told the pressure of the oxygen and asked what is the partial pressure of the helium. Once again, because we have mixed units, I'm going to turn that 8 atmospheres total pressure into millimeters of mercury, and you end up with 6,080 millimeters of mercury for the total pressure. Once again, pressure total is equal to the partial pressures of each, so that's the pressure of O2 plus the pressure of helium, and we can plug in those numbers, so we know that this is 6080 millimeters of mercury is equal to 1,280 millimeters of mercury plus the pressure of helium. Well, now at this point, it's just a quick algebra problem. Subtract 1,280 millimeters of mercury from both sides, and we're going to get 4,800 millimeters of mercury is equal to those there, of course, canceled out, and we're left with pressure of helium. So that is going to be choice C. As a side note, 3 sig figs. So once again, really this should be that, or 4.80 times 10 to the 3 millimeters of mercury. That not only finishes up this section, but it also finishes up this chapter. As I said, there are other gas laws out there, and I wish we could get into them. There's the ideal gas law, and there's also Graham's law. And the ideal gas laws has one of my favorite formulas, mostly because of the nickname of the formula, but you'll have to take a higher chemistry class, hopefully with me, to be able to get into that. As usual, there's a pretty decent this time concept chart here. Once again, I'll remind you, you do need to know each of the gas laws, but mathematically I would always use the combined gas law when doing calculations. And then we also have these extra things here that we've had at the end with Dalton's law, partial pressures, and Avogadro's law. Take a moment, take a look at this one, and of course be sure to let me know if you have any questions.